Have we covered this addition of steam? Look at your notes. Tell me.
No, I don't think so.
Okay, so what we have done, I think this we have done. The mechanism of electrophilic addition is that carbocation forms, then it is attacked by a negative ion, then it gives the final product of the addition reaction.
Yes, we went over this.
Okay, and this one?
Yes.
Okay, so we have to start from addition of steam, I guess, right?
Yes.
So what happens in the addition of steam? We are doing alkenes. Okay, we are doing the reactions of alkenes. So how alkene reacts with steam? So scientists use the addition of steam to alkenes to make alcohols. When you add the steam, that is H2O in the form of gaseous state, to alkenes, it forms alcohols. They react steam and gaseous alkene at high temperature and pressure is the condition. Catalyst is the concentrated H3PO4, that is phosphoric acid, as the catalyst. These are the conditions for this reaction: high temperature, pressure, and a H3PO4 as the catalyst. When alkene is ethene, product is ethanol. When alkene is propene, product is propanol. Here it is written that ethanol, which is found in alcoholic drinks, it is always produced by fermentation of glucose. So you can write this line by putting a note here that ethanol, which is formed after the addition of steam to the alkene, it is actually produced by the fermentation of glucose. So this is the reaction which happens here, that you add H2O to this alkene. This is alkene or ethene. When you add H2O here, then at one carbon you have hydrogen attached. Okay, double bond is converted to single bond, and at one carbon you have OH attached. That means you get ethanol. Okay, conditions are high temperature, pressure, and concentrated phosphoric acid. So write it down, addition of steam. Hello Alicia, welcome to the session. Please turn on your video.
I just joined.
Pardon?
Of network issues.
Okay. So this is the addition of steam. We are learning that when you add the steam to the alkenes, you get ethanol. Conditions required are high temperature, pressure, and concentrated H3PO4 as a catalyst. Write it down.
I'm done.
Reaction of an alkene is addition of halogens. Halogens means fluorine, chlorine, bromine, iodine. This is what ethene. When you add bromine, so at one carbon you have one bromine attached, at second carbon you have one bromine attached. Okay, and the double bond is converted into single bond. So ethene plus bromine, it gives me 1,2-dibromoethane.
I'm done.
So the reactant chlorine, if it is chlorine in place of bromine, it is a very pale green solution which is called chlorine water. Chlorine in the chlorine in aqueous state, it is known as your chlorine water. Its color is pale green. Bromine water is Br2 in aqueous form. Its color is orange or yellow depending on the concentration of bromine water. So bromine water is used to test for the presence of unsaturated, okay, C double bond C bond in the compound. How? That the compound, you don't know if it contains single bond or if it contains double bond. You don't know that if it is saturated or unsaturated. So you shake the compound with bromine water. Okay, if the bromine water will decolorize from orange, then you can say that it is unsaturated. That means double bond is present. So this is also known as your bromine water test. So by color change, you can easily identify that your compound is unsaturated. Okay, because bromine decolorizes only unsaturated solution.
I'm done.
Okay. So this is, you can see that this is the bromine water. If the compound is unsaturated, it decolorizes. So next we will study the mechanism of electrophilic addition to alkenes. Okay. So in alkene, we have double bond. It is formed from one sigma bond and one pi bond. One sigma and one pi bond. So how many total electrons are there in this double bond? One bond contains 2 electrons and two bond contains 4 electrons. So total of we have 4 electrons in the double bond. Although ethene is a non-polar molecule. Why it is non-polar? Because carbon-carbon bonds are there. They both have same electronegativity. That's why it is a non-polar molecule. But still there is an area of high electron density around the carbon-carbon double bond. Why? Because of the presence of 4 electrons. So if the electron density is high here, then what happens? Electrophiles are electron deficient. So they want to attack electron-rich molecules. So this makes the alkenes open to attack by electrophile. They easily attack the electron-rich alkene. Remember that an electrophile is an acceptor of a pair of electrons because they are already electron deficient. So they are acceptor of pair of electrons. Now HBr, it is a polar molecule because bromine is more electronegative as compared to hydrogen. Okay, there's a huge difference in the electronegativity between the hydrogen atom and the bromine atom. In a molecule of HBr, okay, as bromine electronegativity is higher, it contains partial negative charge and hydrogen contains partial positive charge. So in the mechanism of addition, what happens? The hydrogen atom acts as the electrophile. Why? Because we have HBr, okay, bromine is electronegative, so it is partially positive, hydrogen is partially positive, bromine is partially negative. So hydrogen acts as the electrophile because I told you, if you remember in the previous chapter, electrophiles are those which are electron deficient, which have positive charge. Okay, so it can accept a pair of electrons from the carbon-carbon double bond in the alkene. Now the question is that how can a non-polar molecule such as bromine it act as an electrophile? It is a non-polar because in bromine, Br2, both have the same electronegativity, so it is non-polar. As the bromine molecule and ethene molecules approach each other, area of high electron density around the carbon-carbon bond repels the pair of electrons in the bromine-bromine bond. Okay, because electron repels each other away from the nearer bromine atom. So this makes the nearer bromine atom slightly positive and the further bromine atom slightly negative. So we have a polarity developed here when bromine molecule approaches the ethene molecule. So how it happens? See, this is my alkene. This is my alkene. So as I told you that one bromine which is nearest, it forms a partial positive charge, it forms a partial negative charge. So nucleophile always attacks the electrophile. This double bond is a nucleophile, act as a nucleophile because this is electron rich. It attacks to this electrophile and the electron density, both the electrons of this bond, it gets shifted to this bromine atom. So when this happens, then we have a formation of a carbocation. Okay, one carbocation is developed here because you can see the carbon valence is now 3 only. So it is deficient. Okay, that's why it is carbocation. Now this another bromine molecule which leaves in the first step, it attacks to this carbocation. Then we have a 1,2 dibromoethane. So this is the mechanism of the reaction we studied here. This reaction, this is the mechanism of the reaction. So there's a formation of the covalent, there's a formation of the intermediate which is carbocation. Is it clear? Any doubt in this?
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Here that how bromine can act as a, although it is non-polar, bromine is non-polar because of the same difference in electronegativity, but how it can act as the electrophile? Because when the bromine and ethene approaches each other, so the area of high electron density around the carbon-carbon double bond, the electron density is high in alkene. It repels the pair of electrons in this bond. Electrons are present here, okay, in this bond. 2 electrons are present in this bond. So what happens? This carbon-carbon double bond in alkene, it repels the pair of electrons in this bond away from the nearer bromine atom here. So it gets partial negative and it gets partial positive charge.
I'm done.
This is the mechanism of electrophilic addition of bromine to ethene. The complete steps. Write it down. Always remember in organic chemistry, nucleophile attacks with electrophile. High electron density, it attacks with a partial positive charge. And when it attacks, the electron density here in this bond gets transferred to this bromine atom. Since this is a symmetrical molecule, so bromine can attach to this carbon also and this carbon also. It's one and the same thing. carbocation will form at this carbon, which is a symmetrical molecule. So you can make any carbon carbocation, and at any carbon you can attach bromine.
I'm done.
Okay. So as a new bond between the carbon and bromine forms, the bromine-bromine bond breaks heterolytically. That means the complete breakage of bond occurred. Okay, that means the formation of charges happen in heterolytic cleavage. The Br minus ion, which is the bromide ion form, it then attacks the highly reactive carbocation intermediate. So one bromine atom bonds to each carbon atom, producing 1,2-dibromoethane, as shown here. I hope you remember the homolytic cleavage and heterolytic cleavage. In heterolytic cleavage, the formation of charges happens, and in homolytic cleavage, formation of free radicals.
I'm done.
So this is your homework questions for today. State the general conditions used in the reaction between an alkene and hydrogen. Name the product formed when propene reacts with chlorine. Ethanol can be used as solvent. How it is made in industry. What will be formed when ethene gas is bubbled to a concentrated solution of hydrochloric acid? This also we have done. Electrophile you can define. Explain how a chlorine molecule can act as an electrophile. Okay, as I have explained for bromine, same happens for chlorine. Discuss and then draw the mechanism of the reaction between ethene and chlorine, basically between alkene and halogens. Addition reaction I have explained, so I think you can answer all these questions. Ethanol, how is ethanol made? By fermentation of glucose. Okay, when propene reacts with chlorine, all the reactions are same. But in this question, chlorine is used, and I have explained you taking the example of propene.
I'm done.
Study about the oxidation reactions are completed, reactions of alkenes. Now we'll study the oxidation of alkenes. That alkenes can be oxidized by oxidation means addition of oxygen. So they can be oxidized by acidified potassium manganate solution KMnO4, which is a powerful oxidizing agent. So KMnO4 is the oxidizing agent and it oxidizes your alkenes.
I'm done.
Okay, so first reaction is for dilute acidified manganate solution. If this is your alkene, if it is shaken with a dilute solution of acidified potassium manganate, that is KMnO4, at room temperature, so the color of this potassium permanganate is purple color, so it will turn colorless. Alkene is converted into a diol. Diol means two hydroxyl groups, okay, two alcoholic groups, two OH groups, okay. So here I am having an ethene. When you react it with water, it is diluted, so that's why it is water here. And this is your nascent oxygen, which comes from your oxidizing agent, which is your KMnO4. So when you do this reaction, then the double bond is converted into single bond, and at both the carbons you have the formation of diol. So it is ethane 1,2-diol. And this reaction is also a distinguished test to find out if your compound is unsaturated or not, because here also color change happens. Okay, so here what happens, that if you are having an organic compound, you add KMnO4 in it. KMnO4 is purple in color. Okay, so if it is unsaturated, then it decolorizes to colorless, then it decolorizes. Okay, so we can check that yes, our compound which we have taken is unsaturated. If the color change does not occur, if it remains purple, then it is not unsaturated, it is saturated. Okay, so both the test, decolorization of bromine water and by cold dilute acidified permanganate solution, they are a distinguishing test for the presence of unsaturated compound. So this is your water. Water comes from because it is diluted, and this is nascent oxygen, which is given by this KMnO4 oxidizing agent.
I'm done.
Next reaction is hot concentrated acidified manganate solution. First is your cold and diluted. Next is hot and concentrated. This is important. So these are your harsher conditions. Now carbon-carbon double bond in alkene, it is broken completely, and the OH groups in the diol formed initially in the cold and dilute solution, they are further oxidized to ketones, aldehyde, and carboxylic acid or carbon dioxide gas. So what are the products? It depends on what is bonded to the carbon atoms in the carbon-carbon double bond. First of all, write this down. In the cold and dilute KMNO4, you have to just break your alkene, okay, and you have to form a dione. So it is simpler. But in hot and concentrated KMNO4, it is more harsher conditions. So your products are further oxidized to ketone, aldehyde, carboxylic acid, or carbon dioxide. And this 7 is the oxidation state of manganese. This 7 is written. This is the oxidation state of manganese. You can calculate. Plus 1 is for potassium, plus X, plus 4 minus 2 is equal to 0. So you get X, 1 plus X minus 8 is equal to 0. X comes out to be 7. You can connect my charger.